Hello, everyone. Thank you for joining. We're very excited to have you here. Today, we're going to be discussing the versatile and useful deployments of GE MDS's Orbit platform. My name is Jacob Lamatina, and I am a computer tech for Applied Technology Group.
Hello, everyone. Welcome to this webinar. I am Jeff Gellum with Applied Technology Group, handling the microwave deployment, microwave design, and systems. We are glad to be having everyone here with us and going through this orientation of the GE MDS Orbit platform. Applied Technology is a full-service partner of GE MDS, and we support the territories of Northern California, Oregon, Washington, and Idaho.
We support numerous vertical markets all across the range of wireless communication products.
The GE MDS platform is the next generation industrial wireless radio.
GE MDS has a diverse portfolio. They cover a wide variety of radios and other networking equipment.
Some of the basics of the Orbit platform covers the cellular, the unlicensed 902, 928 megahertz channels, the licensed channels which in 220, VHF, 450, and 900 megahertz, as well as 700 megahertz. They are available in two form factors, and let me show you what these are. We have the dual WAN multi-service connect router, big word, shortened down to MCR, and the single WAN radio edged connect router called the ECR, and these are the two units. This happens to be an LN4, which is a 450 megahertz unit, and the MCR is the 900 unlicensed 902, 928 radio.
And the MCR actually has dual uplinks, so there are two connections, which will help minimize the downtime. They also have signal quality-based smart auto failover, so basically for added redundancy, it will rotate to whichever connection is the best. So there's a lot of backups included with these radios to make sure that you're on the top connection.
Customer hybrid communication networks are supported with popular cases such as the licensed narrowband radios conjunction with a cellular unit. So this radio right here is strictly a 902, 928 radio. And on the bench wired up here, let me grab it real quick. This is a cellular unit that has a cellular input here, and it also has the Wi-Fi. So if this was a dual formatted radio, it would have the cellular. You can also have the Wi-Fi in any configuration, as well as the radio that you're looking for, whether it be an LN or an unlicensed radio in the same platform. So in configuring the radios, it's very important to go through and determine what configuration you need before you order. It cannot be changed after the fact, so pre-design is very critical in this application.
Exactly, yeah. The Orbit radio is customized to fit your specific needs. So there are various radio configurations, and we can work with you to identify what your use case is, and we will help you select the radio that will fit your needs.
Yeah, a little bit more about Applied Technology Group has many other services that we offer. Being a full service partner with GE MDS, we also go into the design phase to where we will look at your topology of your system, and we will put that into computer modeling and look at your anticipated RSSI values and signal strength. One of the things that we can't do on paper is determine what the actual is. So we have 3 survey vans with pneumatic masts, as well as a trailer with pneumatic mast that we can deploy into the field and actually service the area that you are looking to have coverage and determine, do we meet the engineered values that we found on paper compared to what we see in the real world. And then if we can go, if towers are necessary, we have worked with many tower manufacturers to where we come up with a design, and we will present that and take a project from conception to fruition and bring it all to working order.
Yeah, we can use poles, we can use mounts on top of buildings, on the side of buildings. We have a lot of different possibilities to really get you service wherever you are. We've worked with a lot of difficult conditions, so we've adapted to a lot of those, and we have a lot of things to fit everybody's needs.
Yeah, so with that, let's get into some examples and show you how this radio can help make the transition. If you have the iNet 2, you can migrate into the Orbit platform. Now, one thing just to keep in mind, the Orbit radio is not a legacy compliant radio into the iNet 2 or iNet. So it is a completely different chassis and chipset. So to make the new radio, you do have to change out from the iNet 2 radio or iNet 900 into the Orbit platform completely. So with that, let's get into some scenarios. Here we have a typical example of an installation that many of you are probably familiar with. We have an office that has a radio function as an access point, connected via serial to its historian or into the network, the polling computer. That radio connects with another radio in the field, or multiple radios, over the 902, 928 unlicensed radio, or from a master unit at a remote site as a repeater, bringing the traffic ball back in on the licensed channels. Finally, the remote radio connects to the remote site using a serial cable. So keep in mind, this is a completely serial application, and the Orbit radio can still continue to do serial traffic. In this case, we assume that both the office and remote site probably have a PLC, a radio, an I/O, or any application device that you're trying to get the signal from point A to point B. The Orbit radios can easily function as replacement in this scenario, which will help you make a more advanced deployment down the road of what it can also handle and offer.
Exactly. As I'm sure that you are all aware, the transition to Ethernet is coming quickly. So a lot of the more modern deployments are already starting off with Ethernet if it's a new deployment. But in a lot of cases, we've had setups where people have been running running serial for quite a long time. So we kind of have to be prepared going forward for that transition that for you either has came or is coming. So one of the great things about these radios is that it does support serial and Ethernet, as well as the kind of translation between both of them. So as pictured here, one side shows serial and one side shows Ethernet. So the Orbit radio can handle that translation between the two seamlessly. So it doesn't matter which one you have on either side, the Orbit will be able to help you with the transition to Ethernet if that's the direction that you're going. And one of the really good things about that is that you don't have to change every single site. If you have serial ran at one site, you can have Ethernet at a different site. So it makes it really easy to do the sites one at a time instead of doing them all at the same time.
Yeah, that's a big point. In this next slide, we see that the Orbit radio can support both the Ethernet and the serial at each time, like Jacob just conveyed. But when you prepare to swap over, that PLC may be a serial device, and you don't have the time or the funds to make that PLC into an Ethernet radio, or it doesn't need to be. If it's you only need to bring an I/O, GE MDS now has a new I/O format that would plug into this radio and bring all of your simple I/O connections right back into your main station. And that's a big factor of what this radio can handle. We have quite a few applications in the field to where the client is running an older legacy serial radio, and they want to migrate into the newer platform. This allows the platform to stay in the serial world and then migrate into the Ethernet. Now, one note on that is signal strength and performance needs to be in place. In the 900 license, the 450 license, Ethernet is traffic it can handle, but it's not to be considered a high-speed Ethernet, meaning you're not going to connect a computer to another computer through this situation. This is a slow process Ethernet, and the SCADA system must be designed in that mindset. It needs to do a pull and response format so that it has time to respond to each pull in that regard.
Yeah, so that is an excellent point. You do want to make sure, typically, when you are swapping over to Ethernet, there is a little more data that is required for each packet of Ethernet versus serial. Everyone knows that Ethernet is going to take up more bandwidth, basically. So you do want to make sure that your signal connection is up to par every time. Every time that you're doing a new deployment, you want to test it out beforehand. Make sure you do the proper surveys, which, as Jeff mentioned earlier, we do assist with surveys as well. So if that's needed, feel free to contact us. So in this next slide, we have another typical example of a more modern deployment with Ethernet on both sides of the radio. So pretty simple, pretty straightforward. Of course, the orbits will support this. So that kind of sums up that, from just serial to the transition between serial and Ethernet to both connected to the radios at the same time, all the way to just Ethernet. All of these kind of configurations, the Orbit can easily support that. So it's nothing to worry about. Whatever your connection currently is, we can move along and help with that transition down the road if it's either that Ethernet that you're looking to go to, or if you want to stick with serial, it doesn't matter either way.
Exactly. Okay, now we're going to get in a little bit more difficult scene, and we'll kind of in talking about these scenes, there will be some questions, and we can, feel free to send in your questions if you have them. We'll see if there's time at the end of the webinar to answer them, but we will send emails out and answer each question that you have in more detail. So with the in any system where you have a licensed radio, you can always do a tell-in link where you can add an iNet or a new Orbit platform, 902, 928 unlicensed radio, as a new access point, and from that licensed radio, go into the 902 to talk your last mile to the other radio, or the remote site that's having an issue. In this scene that we see, that we're showing, there's a tree that grows up into the path. Now that tree can be anything from a building growing up or the foliage just expanding into the Fresnel zone and into the coverage of that link. So you can do two things. We can increase the height of the antenna by building new towers. That can and may not be feasible, and or relocate the path into a new location. Or with the Orbit radio having cellular capability, we can now place a new radio anywhere in the world and have that be the new access point that communicates back to your main office via cellular. And that feature is really where this radio shines, is giving flexibility in where it can go and how you can utilize it. We've got a couple of locations that are just doing exactly that. The deployment of doing a access point to reach all of the remote sites was not feasible based on the terrain and the distance. So we've got 3 cellular units that talk to a local cluster, and that cluster then brings back all of those remote units back to one cellular unit, and then that deploys back over the internet through the system. Jacob's going to talk a little bit more on that phase.
Yeah.
So I'll give that over to him.
Yeah, so the Orbit has many means of connecting radios. So in this case, we're using a cellular interface which connects over public internet. So a lot of you are probably concerned about that, which as you should be. Connecting over any type of public internet, whether you're doing it through cellular or broadband or whatever means that you're doing it over, can be a very risky thing, and especially with our sensitive data that is involved with SCADA, it's something that we need highly secure. So we don't just want it going over the public internet, but fortunately, we have a lot of options to handle how we would go over the public internet to guarantee the safety of your data. As we've recently seen with the situation that took place in Florida, a lot of bad things can happen when people have access to your private networks. Some of them can even be very dangerous. So we need to make absolute sure that the path between the two devices is secure, whether you're going over a private connection or a public connection. Always needs to be secure.
Yeah, this is where the VPN comes in very handy. The Orbit offers the built end-to-end encryption that can pass through almost any interface option. This is highly recommended in an environment where your devices are exposed to the public, including through cellular and broadband deployments. The Orbit offers IPsec and GRE VPN services, including site-to-site and dynamic multipoint. This, combined with their diverse routing and firewall options, creates a truly secure radio into your situation. It's protecting it so that only this Orbit set up to a GRE VPN is going to talk to another Orbit on your network, and that secures if the and we'll get into it in another slide. Gives many options for where you place the radio and how you utilize it. My configuration that I like is when I'm out in the field, I can take this radio with me, have another unit at our shop, not even using it for SCADA at this point. I'm using it for my laptop to connect into the network back at the office over a secure network. Now I can do that through the computer, through our local VPN, but this is an extra step to where it's the protocol of this radio, not the protocol of another computer that could be a little bit more tempted to possibly hack, where another Orbit would have to be in place. They would have to know what it is, and these unique passwords and everything are in the unit, making it virtually, I would say, very difficult to get into and break if at all possible.
Yeah, exactly. With these VPNs, you're dealing with either multiple potentially PSKs or certificates. You're dealing with multiple lines of defense, basically, to even get into the VPN. So it's very secure stuff that can go over cellular or broadband. So there's a lot of variety there. But cellular can be pricey, so why use it if you don't have to? That's kind of our important topic going into this next slide. Many of our offices have internet already, various types, whether you use a WISP or an ISP or whatever the case is, where you don't pay based on the amount of data that you use, and there's so there's no data caps, and you have generally much higher speeds with those types of internet. So why don't we just use that? So with the Orbits, with their connections, you can have both cellular and broadband connected, which can function even as a failover. So you can use the broadband, which will connect with the VPN, and you could also have the cellular connected with the VPN and have both functioning. So you'd probably want to use the broadband as the primary connection, and the cellular just in case as a failover. So There's multiple different means of connecting all within one device, and that can vary depending on the configuration that you want. I mean, there's multiple different ways to configure each radio, so we can design it to fit whatever your needs are. And failover is very important, as I'm sure you're all aware. We want to make sure if our primary means of communication goes down, we'll always have another one. So with that, you can save on cost and you can gain redundancy.
Exactly. You know, and why stop there? You know, in this deployment, in this slide that we're now seeing, there's 3 different lines of communication, all functioning through the same types of radio. And in this scene, you can really see how the Orbit radio is really robust in this situation.
Yeah, and as Jeff did mention earlier, because of the cellular that are with these devices, he did mention going out on the road and connecting back to the office while out and about. So that's one of the really cool things about having cellular. Here in this slide, we do have a work vehicle with an Orbit radio installed, probably powered by the vehicle's battery. Of course, we could connect over Ethernet, but we do like convenience. So these Orbit radios do offer Wi-Fi, so that you can take, one of these laptops, you can take your cell phones or any other Wi-Fi connectable device, and you can hook it up all to the Orbit radio, all built in. So you can have a cellular with the Wi-Fi connection, and it's as simple as connecting back to your office as it is connecting your laptop to any Wi-Fi. So it's very convenient. It's on the road, anywhere you go. This isn't limited to the vehicle either. Whatever or wherever you have internet, you can connect safely and securely behind a VPN, behind a firewall, all built in with the Orbit radio. You can connect it to, if you go to a hotel, although maybe we might not recommend that, but if you go to a hotel or a motel, or if you're in your vehicle, you want to go back to your house, you can take these devices with you, connect over cellular, connect over broadband, whatever you need.
Yeah, that application really extends where this radio can be utilized. It's a SCADA radio and beyond. So a lot of applications we are finding that it can be used in that security realm, that will give you that platform of security within the cellular.
Yeah.
That's a big thing, because as towers become harder to put up in areas where people are saying they don't want to see antennas above 20 feet or so, then you have no other option other than burying fiber than to putting in cellular units at key locations to deploy out to the endpoints that you're trying to reach. So looking at where you can get your height to take care of the necessary antenna height to get to your endpoints. If we can all look at the tree lines as they're growing, and without the use of towers, you're very limited on what you can do. So this radio now opens that door to give you more application on where you can do and what you can connect to.
Exactly. Yeah, they're very versatile products. They can mix into many situations because of how compatible they are, how many different options for configurations that there are. It fills, most of the categories of communication in general that we know for different types of radios, but all in one. So it's very convenient. They are industrial grade, so they're built to withstand extreme environments. The heat that it withstands goes to like -40 or
-40 to plus 70 degrees Celsius.
Plus 70 degrees, or I think it's even higher than that. So it's very sturdy, durable product. They do include 5-year warranties with them. So if there does happen to be some damage with them, that's a pretty hefty warranty there that kind of guarantees the product.
If I may go, one of the nice things with it is the transition between the iNet 2 to the 900. They do use the same power cord, so it's the same power plug, same configuration. However, the ECR and MCR Orbit platform now has a voltage range of 10 to 60 volts DC. where the iNet 2 was 10 to 24 volts, 28, I believe, 30 volts. So it opens the platform up into where you have a microwave system that's deploying, that you've got a 48 volt battery system. Now you can run this over your battery system at 48 volts. You've got runtime, you've got reliability within it without having the fear of a aftermarket power cube or supplying it. You can put redundant, good power source into the radio at an industry standard of 48 volts.
Yeah, so kind of expands that range a little bit, which I'm sure we can all appreciate.
Yeah, exactly.
They are compatible with multiple different devices, such as the master station. The master station we will be going into details on in another video, I'm sure, in another webinar potentially. So that has a lot to offer all in itself, but these devices can reach out to other offerings. So it's not just it's not just inclusive to the MCR and to the ECR. It does expand out to other categories.
Yeah, pretty much what our attempts for this first webinar is to go out and give you an overview of some of the functionality of the radio. We plan and hope in the future to go into more depth into the unit, which quite frankly, there's quite a bit to go through. So to give an overview would be just splashing on the screen certain points of interest, but the first thing to do if you do get, when you do get your radios, we can help set them up to where they're configured before they go out. But the radio has a one-time password that is in the unit, and that can be set up. There's 5 codes that can be stored in it at one time. And what that does is there's no back door into this radio anymore. So no one can learn any secret to try to breach into this radio. Once this unit is programmed and on the system, the only back door into it is the one-time password configuration that you set before it goes out into the field. And that's very important to go through your documentation on the serial number, the platform number of the radio, along with that code. And it's a very simple process. That's one of the things that we will go through in another slide and webinar, is how to set up the initial setup and configuration of that. And when that unit is then needing to go back into a factory default for any particular reason, that code allows you to reset it back into the factory defaulted original state. So that's a key feature within that unit.
That goes on to the security.
Correct,
kind of
definitely, because
advantages.
a lot of people were concerned that there was a back door into the radio.
Exactly.
And so the factory could get in and reset it, and that kind of, in a SCADA world, you don't want anything to be able to breach into your system.
Exactly.
So that solved that aspect.
Yeah,
it puts
that
a
is
burden.
pretty-
It's a huge burden, but on the same side, that is there to protect your SCADA system.
Exactly. And with a lot of radios out there, they do have built-in backdoors for kind of usability, so that it's easier for users to like reprogram them or reconfigure them. So although it is more convenient, it does end up being less secure, knowing that there's just a simple button on the radio that somebody can hold for 5 seconds or 10 seconds and it just reboots the whole thing, So these aim more for the security kind of features of not allowing you to do that. It's very
I think
secure in that
you were viewing it too online, where the radio with the firewall turned off, you could see how many people were trying to breach into that piece of equipment.
Yep.
And then as soon as you turn everything on, that immediately stops. So it's not a matter of if with a SCADA system
It's
unprotected. It's a matter of when.
Exactly.
And as we saw in Florida, it can be a dangerous aspect to have someone tampering with their water levels in your system. So that's not good.
Exactly, yeah. And I think with most systems in general, when you're dealing with SCADA, it's probably something that if something did fail, it's all a lot of the SCADA equipment is mechanical, so it can cause a lot of damage. So we want to make sure that that's very secure. These radios also, going along with that security and other networking types of things, these radios support routing, they support bridging, They do have a built-in firewall, as we mentioned.
Yeah.
They support QoS. They support VLANs, various NATing. So if you want to do, port forwarding, or if you want to do masquerading, whichever type of NATing you want to do, they have so much kind of all compact into one radio. It's really a radio / router. It actually is a router, so it's a combination of two different products. So really what it offers covers so much. As Jeff mentioned, we're really just scratching the surface today. Just to give an overview kind of for all different types of audiences, whether you're new to radios and you just want some basic concepts, or whether you're a designer of deployments, or you're a programmer, or whatever the case is. We hope that we've kind of given you everybody a little bit of information here today. We're trying to target kind of a wide variety of audience here, but we do, for those interested in the more technical details, as Jeff mentioned, also feel free to reach out to us, contact us. We should have our email displayed to contact us, our phone number, everything like that. So feel free to reach out to us with any questions that you have, or if you want to participate in another webinar down the road where we will most likely be going over the details of these radios, how to program them, what to do when you're getting started,
Right.
Different tools.
I would say, send us some ideas of what you would like to see in a webinar, and we could go through that in some depth. And
Exactly.
give that. If I may, real quickly, I forgot to mention one of the aspects in a new deployment of the radio. The units now have what's called iPerf, if many of you may be familiar with it. But what that does is it's a server that can be turned on and activated within the radio. And now from your laptop, you can do a bandwidth test between point A and point B to determine how much payload you are getting through that radio. And that's pretty interesting, because when you're in the field and you're looking at what you want, you've got compression that you can turn on, and also header compression that you can turn on and activate. And on the bench, we've seen, in the 902, 928, the radio is at max performance over the air on a wider channel, can do up to 1 meg. Well, with compression turned on, TCP traffic can go beyond that. So it all depends on your type of traffic you're going to be sending, but compression does allow for greater speeds to go through the radio.
Exactly.
In the 900 licensed realm, and also any of the licensed realm, the radio is going to be a slower platform. So again, I can't reiterate enough, don't think that because it's got an Ethernet port that it's going to be high speed. Yes, it can do Ethernet, but it is slow Ethernet in that realm.
Over the radio.
The 902, 928 world, they have greater platforms where the channels are wider, and they're hopping faster, so they can push a little bit more payload through them.
Yeah, and to be relative, I'm sure that most of you are aware kind of the speeds are generally going to be limited in the SCADA world. I think the maximum bandwidth that these advertise is 1.25 megabits per second.
Right.
So, with the compression, it can push beyond that. So,
Right.
It's all relative. Within a SCADA world, the 1.25 megabits per second is actually, it's pretty good. It's
Now that's in the 902, 928 world.
in the 902, 928,
Correct,
yes.
correct,
Yes. So there are different limits, of course, depending on which ranges that you're running in. But yeah, they have significant speed for a SCADA radio, definitely, and with its compatibility, it's really a great product that's very versatile.
Right.
So I think we covered everything that we kind of intended to cover today. Again, this is just the basics. We have a lot to go over, so we really wanted to give you guys a quick rundown. But thank you all for joining us.
Yeah.
We had a great time, and we really appreciate the support here. Please join us next time for a more in-depth look. Let us know, again, what you're looking for. If you have questions, if we find out that everybody kind of has questions about certain topics, maybe we can put that together in a specific webinar going forward. This has been fun, and thank you guys again. We're very grateful.
Thank you much. This is our first first webinar, so we might be a little rusty,
Yeah.
or not rusty, but we may need some, so bear with us.
Yeah, we're definitely adjusting, working with it, but we appreciate it nonetheless. Thank you guys so much,
Yeah.
and have a great day.